All right, so the last unit of material we're going to look at, the first 2 days are going to be very similar. They're going to be from chapter 9. We'll do 9.1 and the first part of 9.2. And then that's all I really want to get into for chapter 9 because there's a lot more, but we don't really have enough time to do more in 9. So then we're going to do section 10.1, which is kind of its own section that you can do in 1 day. So we're going to be looking at what are called parametric equations and graphs. We'll do a little bit with polar, but we're never really going to get into graphs in polar. So when we start looking at how we've been doing graphs on the calculator, everything that we've been doing has been in what we call function mode, okay, all year. If you click on mode, the first option right under where we change between radians and degrees is function. And that's the mode we've always used. When you press y equals, then you can type in different equations. Well, there are other modes on the calculator. One we're going to look at today is parametric. Another one is polar. We'll look at a little bit maybe tomorrow. But the idea in polar is you can draw all kinds of different graphs that normally we can't really do as functions, okay? Graphs that fail the vertical line test. So I can draw something, actually if I make that look correct, you'll see it is a circle. I could also take and draw something like a spiral. I can make it spiral as much as I want. Okay, in that case, that's just one spiral. I could draw a shape like this. It's a little hard to see, but that shape is called a cardioid because it kind of looks like a heart. It's hard to see, but it does dip in. If I zoom in a little bit, you can see that the top part kind of dips in. So it's kind of like a little bit of a rounded heart. Can also do something like this to it.
Is this stuff that you do in calc?
In calc? You might do a little bit with polar and parametric in calc. I guess it depends on the teacher and the topics. So that's another picture, kind of like the heart one, but it actually doesn't just dip in, it actually loops. It's called an inner loop. It comes back in and makes a little loop inside. So all kinds of different graphs that we've never seen before that you can do. I'll do one more. Let's do something like this one. This is going to look like a flower with 5 petals on it. And I can change the number of petals. I can change the length of the petals. Do all kinds of things. Okay, so parametric and polar really let you graph all kinds of different things that normally would be very hard to do. Here's one. Here's one that's really fancy. I don't know how to make that one. It's probably a pretty complicated equation. This one's probably a little bit simpler. And the last one, that one's also a little bit simpler. We don't really get into much of even the graphs I just showed you with like the flower and then the heart one. We don't get into a lot of them. I'm just showing you the different kinds of things that you can do.
Where would these graphs, like what data would you get to make a graph like that?
These would probably, so all the ones that I showed you here, I think used like trig functions. So the data would come from like a sine or a cosine. If you change it, that's a cosine. I don't know if you can tell, but with a cosine graph, it always has symmetry over the x-axis. So if you took this part and you folded it down, it would land right on top of that part. This leaf would land on top of that one, and that one would land on top of that one. So cosine is one function that the data could come from. Sine would be another one. If you look at sine, sine's a little different. It still has 5 petals, but the symmetry is different this time. In this graph, you could fold it on the y-axis. This petal would land on top of that one, and that one on top of that one. But yeah, a lot of different trig functions is where this data would come from. The circle one that I drew, that was not a trig function. That's the simplest graph you can do in polar, and it's just a single number.
Where could you get data for that, though? Like, what's an example?
An example, like this kind of graph. So that would be something let's say you were anything having to do with like a circle. So I'm trying to think of like a word problem. Could be something from geometry where you were given a certain distance from the origin that was fixed, and then you had to create that shape, and it would be a circular shape. So a circle would have to do with anything that you're measuring where a fixed distance from a single point.
4 is the radius?
Yep, 4 is the radius there. Yep, that's a circle of radius 4. If I change it to a 5 or a 6, you get a circle of radius 6.
Is that what the R stands for?
R stands for radius, yep. Circles are the easiest graphs you can draw in this mode. Spirals are also pretty easy, but the other ones I started to show you, then trig starts to get involved, so they get a little bit more complex. All right, so let's take a look at how we're going to do some graphs on the calculator and how it's going to look. So when you're in polar mode, you're going to see an R. First mode we're going to look at is parametric. Okay. This is going to look a little bit more familiar to us. It doesn't have an R. It has what we're used to seeing, which is a Y, but it also has something else. It has an X. So when you graph something in what we call parametric, it's similar to what we're used to because it doesn't use the letter R. But it requires you to type in 2 equations to create one picture. Any of those pictures that I just showed you on the screen where it said R, I could have done on this screen as well. Let's see. So 1 equation for X, 1 equation for Y. So what you're basically doing when we graph something in this mode is you're using 2 formulas. You're going to say, all right, use this formula to calculate the X value of your coordinate. Use this formula to calculate the Y value. So it's like you're breaking your coordinate into 2 formulas rather than just using 1. And what 2 formulas allows you to do, it gives you more flexibility of the kind of things you can draw, right? Because you're not limited to 1 formula. All right, so let's say that these are going to be the 2 functions that I would type in to the calculator. We'll call the first one F, and we'll call the first one G, the second one G. The formula that I'm calling F is going to be the formula that generates all the X values of my coordinates, and the formula G is going to generate all the Y values. They don't have to be named F and G. I just chose those 2 letters. If you take all the different points that formula F generates and all the different points that formula G generates and you draw the entire picture, we call that a curve. Okay, so when you draw things in this mode, they generally call everything that you sketch a curve. Okay? This is a curve, this is a curve, that's a curve. These are all different kinds of curves. They have, some of them have specific names, like this is called a 5-petal rose curve. I think I showed you a spiral. That's called a spiral curve. But everything is some kind of curve. The one that looked kind of like a heart, kind of drew that one. That's called a cardioid curve. They're all curves. You're not going to have to know the special names that I just said. So the 2 formulas that you type in, they are called parametric equations. You have one for X, and you have one for Y. When we do an actual problem, they'll give you a formula. Let me show you an example. Here's an example. Here's your X formula. Here's your Y formula. And notice, what letter are they using in each formula? T. Okay, they use the letter T. So T is not a letter that we're really used to using when we type things in on the calculator. But when you are in parametric mode, that is the letter they use. So when you press the button that used to give you an X, now it gives you a T. So it's just a change in the letter that they use. This button right here will give you 4 different letters depending on which of the 4 modes you're in. We're really only going to talk about the first 2. We'll do a little bit in polar. That's what I was showing you guys earlier.
Does it go in order?
But we're going to do it on paper. We're not going to use the calculator to do polar tomorrow.
Does it go in order? So x's function is
Yeah.
there.
Yep.
Zero, or the, is
When
that
you're in
theta or
polar,
zero?
that's a theta. Yeah. But when you press the button now, it'll give you a T instead of an X. And that's because I'm on this and not that.
Will radian and degrees mode still play a factor?
Yes. Anytime you type in sine, cosine, tangent, anytime you press one of these 3 buttons, then whether you're in radians or degrees will change the picture. If you're just typing in something that doesn't have sine, cosine, or tangent, like a number, then no. Radians or degrees would not make a difference. So for the problem that we're going to do in a minute, there's no sine, cosine, or tangent anywhere in that problem. So whether you do it in radians or degrees, it makes no difference. Okay. And that letter that we're going to be using, T, normally we call it a variable. Well, in parametric, they call it a parameter. Parameter, it means the same thing as variable. So if I ask you what value are you plugging in for the parameter, I'm basically just saying what value are you plugging in for the variable T. Same thing. Okay. Anytime you draw a curve on a calculator, it has a start point and an end point. So you probably didn't notice, but when I drew this spiral, it started at the origin and it spiraled out. So it started here and it stopped here. Okay? Just because you know where something starts and stops, that doesn't necessarily tell you what it looks like. Like, look at the spiral. It started at a point like that, stopped at a point like that. There's a lot of ways to get between those 2 points. You could have just a straight line. You could, do the spiral like we did. You could have all kinds of ways to get between those 2 points. Okay. Now, some graphs start and stop at the same point. So when I drew this one, I think it started right here. And the way that it drew it was like this, and then it went like this, and then it went like that, like that, like that, and then it stopped. So I just, I just know that from doing them. But this particular graph starts and stops at the same point. So knowing where a graph starts and stops is helpful, but it doesn't always tell you what everything is going to look like. Okay? Sometimes we need a little more information. But we're going to practice at least learning how to find where a graph starts and stops, because it's helpful. And where a graph is going to start and stop is going to depend on your variable. It's going to depend on your parameter. So when you look at these 2 formulas, look at this part right here and that part right there. What numbers would you be allowed to plug in for t and then double it and subtract that from 1 and not get some kind of error? Think about when do you get an error on a calculator when you're trying to do a certain arithmetic? What's one thing you could do that would give you a problem? Yeah?
You don't get it equal to 0, like you wouldn't try and make that.
So what's one thing you can do that would give you an error on the calculator?
Get a 0 for an answer?
Something with a 0. Yeah?
Divide by 0.
Divide by 0. Well, is there a letter in the bottom of a fraction here? In either one of those formulas?
Oh, there's a.
No. So there's no letter in the bottom of a fraction. So you'd never be dividing by 0 here. So that's not a problem. What's the other thing that can give you an issue? Dividing by 0 and
Square root?
square roots of what?
Negatives.
Negatives. Are there any square roots in this problem?
Nope.
No. So technically, you could plug in any number you want for t. There's no restriction mathematically here. You can double any number you want and subtract that from 1, and you'll never get an error. The only restriction would be is if they tell you there's a restriction. And in this problem, they are going to tell you. They're going to tell you they only want you to use numbers between 0 and 1. Is that because if you use other numbers, there would be a problem? No. They just don't want you to use other numbers. So you have to stay between the two numbers they give you. So when I say here that the start point and the end point are dependent on the parameter, I mean they're dependent on what they tell you you are allowed to use. In this case, it's only numbers from 0 to 1. So let's say that we have a parameter. I don't want to use 0 to 1. That's specific. Let's just say we have a parameter and we can plug in numbers from A to B. The low value that they allow you to use, that is going to control where the graph starts. The high value that they allow you to use is going to control where the graph will stop. And how do you figure out exactly where it starts and stops? And let me add the word controls the start and controls the stop. It's not the start and the stop, but it controls where it will be. To figure out where it's actually going to start and stop, let's do the start. You're going to take the low value and you're going to fill it into your formula for x. And then you're going to take the low value and you're going to fill it into your formula for y. And that's going to tell you where your graph will start. To figure out where your graph is going to stop, you're going to take your high value. You're going to plug that in to the formula for x, which will be given to you. And then you're going to plug that in to the formula for y. So there's 4 calculations you need to do. Plug A into 2 formulas, you plug B into the same 2 formulas. And that'll tell you where you're starting and stopping. And again, just because you know you start here and you stop here, that doesn't tell you exactly what the graph is going to be. It could be a spiral, it could do something like this. We don't know. There's a lot more information we'd have to figure out in between the start and the stop, which we don't get into as much in this class. Okay, so here's a formula, and it tells me that x equals 1 minus 2t. So this is the formula that's going to generate the x values. Y equals 2 minus t. That's the formula that's going to generate the y values. And the only numbers that you're allowed to fill in for t are numbers between 0 and 1. Okay, so let's figure out where this graph is going to start and where it's going to stop. Okay. What number in the numbers I'm allowed to use that I can fill in right here and right there, what number there is going to control where the graph will start? 0. So to find where the graph is going to start, we're going to take 0 and we're going to fill it in for t in both formulas. Plug 0 into the x formula, and then plug it into the y formula. But we've got to figure out what that comes up to. Okay, so let's plug in 0 here. 1 minus 2 times 0. plug 0 in here. 2 minus 0. So where is this graph going to start? Yep.
-1, 2.
So if you were going to draw this graph, you would start at the point -1, 2. And let's see where the graph is going to stop. What number is going to control where it stops? Yep, the 1, the highest value you were allowed to fill in for t. So plug 1 into the x formula. Plug it into the y formula, and tell me what you get. So now instead of a 0, fill in a 1. So it's going to be 1 minus 2 times 1. And the y formula, 2 minus 1. So where is this graph going to stop? Yeah. -1, 1.
On the left side, it's 1 minus 2 times 0. Wouldn't it be 1, not -1?
Yeah. Sorry, I don't know why I put that. 1 minus 2 times 0, that's 1 minus 0. So think about what would happen when we draw that. Or, actually, think about first when we draw a graph, something we haven't really thought about, but it's happened all year. What direction are graphs drawn in when you hit graph on the calculator? When you start to see it on the screen. The graph always is drawn from, yeah, it's always drawn from left to right. So like if you were drawing a sine wave, you'd see it appear on the screen like this. Left to right. Think about these 2 points. We're starting at the point 1, 2. There's 1, 2. And we're stopping at the point -1, 1. So -1, 1, somewhere over there. What direction are we traveling in if we go from 1, 2 to -1, 1? We're traveling what? To the left. We're drawing from right to left. So let's draw this. And you're going to see that it draws it in a direction opposite of every graph we've done all year.
Is that just because it's parametric?
Yep, it's because it's parametric and it has to go from the start to the stop. It can't draw the other way. It always draws start to stop. So we have to put in our 2 formulas. Scroll back up. So we go to y equals. For x equals, it's 1 minus 2t. And for y equals, it's 2 minus t. Okay, before we graph, what do we always have to do? Yep. Always have to set the window. Now, when you press window, there's a lot of things there we've seen before. There's a couple things that are new. What's something up there that's new? Yeah?
T min max?
Yeah, so in addition to the x min max, y min max, now we have a t min max. We also have a t step. I'll talk about
Scale.
the t step later.
Scales.
Scale's always been
Oh,
there.
scale's been there.
No, I'm
Yep. So t min max, that's the domain for t, the low value and the high value. So we need to put those 2 numbers in. So t min, and the highest value you can use for t is t max. Okay, for now, just put the t step at, let's do 0.05.
What is the T step?
I'm going to explain that in a little bit. Now, I don't need a very big window. I'm only looking from here to here. So if I go like 3 units up, I don't even need to go down, but I'll just go 3 units in every direction, and that's more than enough to see that graph. So it's -3 to 3, and -3 to 3. And watch it, it is going to draw from the upper right to the lower left. Happened quick, but it did. Okay, I could slow it down a little bit. If I do this, it'll be 5 times slower. I'll explain why it's slower in a little bit, but that's the sketch. So that is the simplest possible way you could connect those 2 points. That is a line segment. And let me save that graph. Just put that there. Any question on that? Once you're looking at the picture, there is no way to tell where it started and stopped. I can't tell if it went right to left or left to right. Only way I could tell that is if I watched it while it was doing it, or if you gave me the original formulas, I can figure it out. Yep.
How do you type T?
You press the button that used to be X.
But it didn't let me just type X.
You need to switch the mode so it says parametric. Yep.
The parametric polar.
Parametric. Yeah, we're not, I showed you guys a few things in polar, but we're probably not going to do a lot with that. It was just easier for me to show you what I wanted to show. But anything you can do in polar, we can do in parametric. Okay, any questions on that one? All right, let's look at this one. So what I want to do now is I want to look at that problem we just did, but I don't want to do it parametrically. I want to do it the way we have been graphing all year. So what I want to do is eliminate the parameter. I want to get rid of the t. And when I'm done, I want to have something like y equals, in this case, it'll be like a y equals mx plus b. Okay, a line with a slope and a certain intercept. Okay, what does that look like the intercept is there? Yeah. Yeah, it looks like it's about 1.5, 3/2. And the slope, well, the slope's probably not 1. If the slope was 1, it would be at a 45-degree angle. So it's a little less than 1, maybe a half. We don't know. But the slope is definitely less than 1. So let's see if we can figure out how to make this in y equals mx plus b form. And we're going to do this with the example problem that we just had. Now, I say that what we're about to do is sometimes doable. If I give you a problem and the directions say to eliminate the parameter, it will be doable. I'm not going to give you a problem that says to eliminate the parameter and you can't do that. There are problems that in math you could have that are like that, but we won't. Okay, so here's our 2 examples. So the goal when we're done is to no longer have a t in the formula, and we want to merge these 2 equations back together into one equation, like y equals mx plus b. To do that, we're going to start with this one, and we're going to rearrange it somehow. Anyone have an idea of how we're going to rearrange this equation? Yeah?
How do you change it to get t by itself?
We want to get t by itself in this equation. That's the first step. So let me write that down. So step 1. Isolate t in the equation for x. Okay, so I'll do that. I'll do it off to the side. So I'm going to add, first I'll subtract the 1. And after I subtract the 1, what else would I need to do to finish getting t by itself? Yep.
Divide by -2.
Yep, I'm going to divide everything by -2. So that's gone. x divided by -2, we can just think of that as this. Pretend like there's a 1 in front of the x right there. So that's really -1/2 x. And -1 divided by -2, what does that come out to? Plus 1/2. And there you go. So that's your formula for t. What do you think we're going to do with that formula now? Yep. Plug it in where? Yep. We're going to take that and we're going to fill it in right there. So that's step 2. So now you're going to plug in for t in the y equation. And the last step is to simplify. Okay, so let's do that. So now we have y equals 2 minus, and now fill in what you've got for t. -1/2 x plus 1/2. Okay, what are we going to have to do with that negative that's in front? We're going to have to distribute it. And we're going to end up with y equals -1/2. So that's 1/2 x. That's our slope. And what's 2 minus 1/2? Yeah. 1.5. And if you remember when I asked you what is the y-intercept, someone said it looks like it's at about 1.5. That's exactly what we just got. So the y-intercept is at 1.5. So if we graph that, that's a function, it should look just like the picture we did. So it's straight. So we'll keep this here, and we're just going to label it. This was the parametric. Now let me type in the function and see if it looks the same. Okay, now to type it in as a function, I have to switch back to function. When I switch back, everything about my window is going to stay the same. Remember I set it from -3 to 3? It's going to keep all that. Okay, so that's all fine. Now just type in 0.5x plus 1.5. 0.5x plus 1.5. Okay, and compare the two. Okay. Do the two graphs look exactly the same? So is this picture identical to that one? No, not quite. When you draw something as a function, the calculator draws it forever. When you draw something parametrically, it starts and it stops somewhere. This one is supposed to start and stop at two values we already know. It was supposed to start at, where did we do it? Oh, right here. It was supposed to start at 1 and stop at -1. When you graph something as a function, the calculator doesn't know that. So I can tell the calculator that by putting it in parentheses next to it. We want this graph to only go between -1 and +1, left to right. Is there any question why we only want it to go between -1 and 1? We want it to stay right in there. Shouldn't go beyond those two lines. Okay, so let's tell the calculator to do it that way. So next to it, tell the calculator you only want to go bigger than -1. So x, and then you're going to press second math, and that's how you get the greater than or equal to symbol. Second math. So by doing that, I'm telling the calculator only go from -1 and up. So that'll fix part of it. Okay, so now it's starting at -1 on the left, but where do we want it to stop as it travels? We don't want it to go past, yep,
You don't want to do this.
we don't want it to go past 1. So I'm going to tell it that too. Don't let x go past 1. You're only allowed to go right up to 1. Now when I graph it, let's compare the two. Those two pictures look pretty similar now. Yeah, there's nothing I can do about this part. Since I told the calculator not to draw here and here, it doesn't know what to do. So it says, well, I'm going to do something. So it just fills in that blue spot. I guess if I wanted to kind of cheat and make it look really good, I could do that. Just draw on top of it so you can't see it. Now they look identical. So that's the function, and that is the parametric. So when you draw something as a function, part of it is you have to tell the calculator where to start and stop. So let's write that down. Okay, so remember, when we do it parametrically, we only had a small section. So we have to restrict the domain. And that has to go with your answer. If you don't put that, you're just telling the calculator draw forever. But we don't want forever. Okay. And how do you figure out those two numbers? That's what I showed you the first thing. You find your start point and you find your end point of your curve. And all you have to worry about is the x values. You don't, when you're describing where to start and stop, you never describe it in terms of y. Always describe it in terms of domain, which is x. Okay, so that's called eliminating a parameter, and there'll be a couple of those on the test. So step 1, solve for t in your x equation. Step 2, plug it in for t in the y equation. And step 3, simplify, whether you have to do distributive, combine like terms, but simplify whatever you get. And that's your final answer. Yes?
Is it going to be somewhere separate on the test to like put in the domain and stuff like that, or we're just going to put it into one?
Yeah, if you have to put it, there'll be a spot where you would know where to put it.
Okay.
Okay, let's try another one. Eliminate the parameter. Okay, what's the first step to eliminating the parameter? Yeah.
Isolate t in the x equation.
Isolate t in the x equation, and what would t come out to?
T equals x plus 1.
Yep. So that's step 1. What's step 2? Yeah. Plug it in where?
Somewhere.
4?
What?
Where are you plugging it into y?
For the
For the t. Yep. So replace t in the y equation with x plus 1. So now you've got y equals x plus 1 squared. And there's our equation. And what kind of shape is that if you drew this? Yeah? It's a parabola. Yeah. Specifically, it's a parabola that's been shifted 1 unit horizontally, because it's inside, to the left. Now, is it supposed to be an entire parabola, or was it just a section of a parabola? Yeah. It was just a section because they gave me a start and a stop value. If they didn't give me what I just underlined, then fine, you could draw the whole thing. But they're telling you where to start and stop. What number is going to control where the graph starts? Yep.
0.
0. So plug that in. And when I'm describing my restriction over here, I only care about x. I don't care about the y. If you plug in 0, what's 0 minus 1?
Negative 1.
Yep, negative 1. So just put that off to the side. Now plug in 3. What's 3 minus 1?
2.
2. So this particular graph should start at negative 1, stop at 2. That's your entire answer. Start at negative 1, stop at 2. You could write it separately if you wanted to. X is greater than or equal to negative 1. And I don't like to write it the second way, it's more writing. But you could.
I'm lost.
I was confused on why he was using, are you confused on why he was using the left equation and not the right?
I wonder what they are.
So I plugged in
The I is just the domain,
0,
like the restriction.
and then I plugged in 3
Got it.
to figure out the
Never mind.
x value of where my graph started and
We're good.
stopped.
We're good.
Yeah, I never plugged these into y because I don't really care about y. Not for
That was
this.
the restriction.
For the restriction, I only care about x. If you said to me, find the coordinate of where the graph starts, well, then okay, now I need y. But this question didn't say that. Okay, let's graph this one and just make sure it looks like what we think. I'm not going to do it as a function this time. I'm just going to do it parametric. So we've got t minus 1, and we've got t squared. Always set your window. So 0 to 3. And let's do the t step at 0.1, and I'm going to talk about the t step now. Let's hit graph. Negative 3 to 3 wasn't enough, so let's go. Set the y max at 6. How high do I? Well, 3 squared is 9. So let's just set the y max to 10. If you don't know where it stops, you're going to be guessing like I did. So sometimes it's quicker to just figure out where it stops. Okay, there's your sketch. Starts at negative 1, stops at positive 2. And that is a parabola, but it's just a section of it. Now, people are asking about that t step. What the t step does. Anybody know?
It was like, well, the first time I saw it was like the speed of how quickly the graph was drawn.
It does control how quickly it's going to draw because it's controlling the amount of calculations that are being performed. So what the t-step does is think of this as an increment. Okay? You're traveling from 0 to 0.23, and the step is the increment that you're traveling in. So you're traveling in increments of 0.1. So the way the calculator is going to graph this problem is it's going to take 0, and it's going to fill it into the formula and get a point, and then it's going to plot it. Then it's going to plug in 0.1 into the formula, and it's going to plot another point. Then it's going to plug in 0.2, 0.3, 0.4, 0.5, 0.6, all the way till you get to 2.7, 2.8, 2.9, and then it gets to 3, and it stops. So what it's doing is it's controlling how many points you graph. So if you go from 0 to 3 in increments of 0.1, I think that would be 31 points. Think about like counting 0 to 30. That's 31 numbers, including the start and the stop. Now, if you change the increment to be 0.01, what's going to happen now is it's going to plot points from 0 to 3, and it's going to do every single point in increments of 100th. So that's going to plot 301 points going from 0 to 3. Count by 0.01. It's 0.01, 02, 03, 04, 05, all the way till you get to 3. Right? It's going to draw that one a lot slower. But there's more detail. Can you see that there's more detail? Not really. this particular screen and this particular curve, I don't think it looks any different between those two. But if I don't do enough detail, you will definitely notice it. If I count by ones, think of how many points it's going to plot. You're going to get one at 0, then you're going to go to 1, 2, and 3. So you're going to get 4 points equally spaced on that graph. So what you're going to end up with is something that looks like this. It's going to look like 3 line segments. It's not as smooth of a curve, right? So if things start to curve and you don't use enough points, it's going to start to look jagged. Right? I mean, it doesn't look awful, but I think you can tell it's not curved anymore. There's definitely 3 line segments. And then if I did something like, let's say I did a t-step of 3. How many points do you think I'd get now? Just 2. I'm going to get one at the start, and then it's going to add 3, because that's my step, and then I get one at the stop. So now it just looks like a line segment. But that's not what this picture should look like. It should have a curve. If you put in, you might think, well, I'll just put in a really small number. That way, no matter what, I always get enough points and it'll look curved. Well, that's plotting tens of thousands, hundreds of thousands of points. That's going to take a long time. Okay? It's graphing. I don't know if you can see it's graphing, but there's a tiny little blue dot that's slowly moving. You're probably going to be there for about 10 or 15 minutes.
Can you
put
speed it up?
Well, I can stop it. So once you graph it and you hit graph, the buttons aren't going to respond, no matter what you press. So if this yellow circle is spinning, you press second off, and that stopped it. And now you can see if I go back, well, okay. So I did the same thing I didn't want to do. Press second off again, that'll stop it. But go to your window before you hit graph and change your t-step back to something more visible. Now you get a good graph. Okay. So second off is how you stop it. Okay. So that's what the t-step is. I'm not going to worry about that. All right. Let's see if we can graph a circle. Okay. Circle is pretty easy in parametric. Not that easy as a function because it fails the vertical line test. You can't. The only way I can draw it as a function is if I kind of cheat and do the top half and then draw the bottom half as a separate. And it's not even really a circle, it's just 2 semicircles together. But we can draw a real circle in parametric. Let's think about this point right there. If we can figure out how to draw one point on a circle, then we can figure out how to draw all the points on a circle. We just need to figure out how to do one point. When we do things parametrically, how many equations do you have? When you type it in on the calculator. Yeah?
It's just 1.
As a function, you only have 1.
Right.
Parametrically?
It's
2. One equation is for what?
2.
X, and the other equation?
Wow.
Y. So let's see if we can break down and figure out how to find the x value of this point and the y value by making a triangle. This is the x, this is the y. Normally, what kind of letter do we use for an angle in trig? Yeah.
Theta.
Yeah, we normally use theta or some kind of Greek letter. Well, when we do things parametrically, what letter do we use? T. T. Always use T. So T is going to represent that angle. What trig function would help me to find x in that right triangle?
we talking about? Like sine, cosine?
Sine.
Oh.
Yeah,
Cosine.
cosine. Now, I don't know the hypotenuse, but I know in a circle, the hypotenuse of that triangle, we also can just call the radius, so I'm just going to call it r. And what would be your formula, Jack, using cosine?
Adjacent over hypotenuse.
All right, and what would you, so can you tell me what you'd fill in there using what you just said?
Oh, cosine t
Yep.
equals adjacent y over r.
What side is adjacent?
Oh. Wait, oopsies. X over r.
X over r. And now solve that for x. How would we move the r to the other side? Yep.
By both sides by r.
Yep. So if you want to graph a circle, that's the formula you have to type in for the x. R cosine t. What formula would help me to find y?
Sine.
Sine. And what would be your formula using sine?
Don't make me do this again, please.
Yep.
Sine t equals y over r.
Over r. And solving for y?
R times sine t.
Yep. R times sine t. So that's your formula that you have to type in for the y value. So when you want to graph a circle in parametric, those are the two formulas. You just have to tell me how big of a circle you want to draw, and you fill that number in for r. If you want to draw a circle that's 5 units in radius, change the r to a 5. So let's try this one.
Mr. Hager,
I want to draw a circle that has a radius of 2. So you're just going to take the formulas we just wrote down and change the r to what I'm asking you to do in that problem. So what do you think your x formula would be? For example 4.
Could you read it, please?
So what do you think your formula for x would be in example 4? Yep.
2 cosine t.
Yep. 2 cosine t. And what about your formula for y? Yep.
2 sine t.
2 sine t. That's how you draw a circle. Now, in order for t to go through all the different values you could have, t would have to start at what number and stop at what number? To go through one full cycle. Yeah.
Is it 0 and 360?
0 to 360. Yep. If you don't go 0 to 360, you will not get a full circle. So let's, since you said 0 to 360, that means you're doing degrees. So we're going to start at 0. Let's just go 180. I'll show you what happens. Now, what would be a good t-step value if you have to count from 0 to 180 and I don't want to have thousands of points? Yeah?
1.
Yeah, you go by 1. 180 calculations to do is not
How
bad.
fast does it do 1 point? Do you know the speed of it? Like,
What's that?
Does it do like 10 points a second?
It depends on the complexity of the formula. So if the formula is more complex, it might go a lot slower. Yeah. So we got 0 to 180. Again, we want 360, but I'll show you what happens with 180. Go to y equals. Do 2 cosine t. 2 sine t. Hit graph. Well, I guess 1 was a little slow. Not awful. And it doesn't look elliptical because of, I mean, it looks more like an oval because of my window, but it is a circle. If you count, that's 2 units, and that's 2 units. It's just the window isn't proportional. If you want to make it look proportional, you could always do zoom 5, and then it'll make it actually look equal spaced in every direction. But we only went to 180. If you only go to 180, we can half the circle. You got to go all the way to 360. And I don't want to go by ones. I'm going to go by fives. Okay, so now it's going to draw it 5 times as fast, and I don't think you'll see any loss in detail.
If you draw over 360, does it just start overlapping itself?
Yeah, it would trace over itself. That's a good picture. Now, what would not be a good picture is, let's say you went by 90s. What's going to happen if you go by 90s? How many points would you get?
You guys were.
Well, you get 0, 90,
180,
180,
270,
270,
360.
and 360. You're going to get 5 points where the end point is back at the beginning, but it's only going to be 4 distinct points that form the corners of a square. So there's not enough detail there to actually see the graph. Okay. So if you went by 10s, that would probably be okay. It doesn't look that much different. I can see there, it looks a little bit flatter on parts of it, if you look closely, but it's not awful. Fives was good. Okay. Any question on that one? So that is how you draw a circle. And if you don't keep these two numbers the same, which you always should for a circle, you will start to get an oval. If you make one a 2 and make one a 3, it would become an oval. Oh, we're not going to do that. So notice here, for your circle, it only goes 2 units right, 2 units left, 2 units up, 2 units down. The circle was completely in that section. But what did I have to do for my parameter to get a full circle? I had to go 0 to 360, or if you were doing radians, it would have been 0 to 2 pi. So what I'm trying to point out here is that there's a difference between the domain and range of the picture and the domain of the parameter. Okay. You don't go 0 to 360, you don't get a full circle. You get a half circle, or whatever you do. Okay. And the last one, we're just going to look at, I give you 2 equations, and I just want you to draw what they look like on the calculator. Okay, so it says find the graph. Here's your formula for x. Here's your formula for y. And there's your t min and your t max. So let's put all that in. So t cosine t, t sine t. So that's it for typing in that screen. And now the 0 to 4 pi, that goes under this screen. Now, t is an angle. I know it's an angle because it's right next to a trig function. They used 4 pi. What units does that mean they used?
Radians.
They use radians. Okay, they didn't tell me radians. I have to know by looking at it that t is an angle and there's no degree symbol. So let's switch to radians. When I go from 0 to 4 pi, we only have to go 0 to 12. So we could try going by 0.1. It's probably going to be enough points to see the picture. If it's not good enough, we'll make it a little smaller and get some more detail. Now, think about your graphs of sine and cosine. There's sine. There's cosine. Let's start with cosine. What's the highest that cosine ever goes? 1. And what's the lowest? -1. What's the highest and lowest that t goes? Yeah,
Highest is 4 pi, lowest is 0.
lowest is 0. So let's take the highest value you could have here and multiply by the highest value you could have here, and that'll tell me the highest value you could have there. Highest value for t is how much?
4 pi.
4 pi. What's the highest value you could ever have for cosine?
1.
1. What's 1 times 4 pi?
4 pi.
So your x value will never be bigger than 4 pi. Let's try the smallest. What's the lowest that cosine could ever be? -1 times what number here would give you the lowest value you could ever get?
0.
We could go lower than 0.
Is that type 1?
What's that?
Is that type 1?
Well, the lowest you can get here is -1. But what could you put here to make this number as low as possible? If you put 0 here, 0 times -1, that's only 0. You can go lower than that. Yeah?
Would you just put in 1?
Well, if you put in 1 here, 1 times -1 is -1. We can go lower. Yeah?
Is it negative infinity or as low as 1?
No, t is limited.
Is it limited by, so what is it limited by? Because I thought that's what
T has to go between 0 and 4 pi. So pick a number from here times -1 that would make it as negative as possible. Yeah?
4 pi.
If t was 4 pi and this was a -1, what's 4 pi times -1?
Negative 4 pi.
-4 pi is the absolute smallest that this graph could ever go on the x-axis. It cannot go any smaller than that. Now, same idea for sine. What's the highest that sine could ever go? 1. What's the lowest? -1. So if you took the biggest value you could have here times the biggest value you could have here, what would you get?
4 pi.
4 pi. And that's the highest you could ever go on the y. And what would be the smallest number you could ever get here?
Negative 4 pi.
Yep, we could get a -1 for sine times 4 pi, which would be -4 pi. Okay, so that's the hardest part, setting up the window. And then let's graph it and see what we get. Okay, so we're getting a spiral, and because it went 0 to 4 pi, that's twice around. If I went to 2 pi, it would be once around. Now, when I set my window, I have a lot of extra space here, here, and here. I knew I was going to have extra space. That's not an issue. Okay? When I set my window, I try to set it for like the worst case scenario, right? The biggest and smallest that it could ever be in any direction, even if it doesn't use all that space. That's fine. But that's how you figure out your
Can you go back to the y equals screen for a second?
So the y equals is just the x and the y equations.
Where did you put the like 0 is greater than or equal to t? Because I put it in the same way as it's that.
Tmin and Tmax. If you don't set your Tmax, like let's say you go by ones, do you think that's a good picture of the spiral?
Oh,
No. Not too blocky. Okay, so 0.1 is good. It shows everything pretty smooth, and it's a reasonable amount of time. It doesn't take too long to draw it. But the bigger you go with the spiral, the more blocky it's going to start to get, because as the arm of the spiral goes out, any parts that are straight are going to get magnified more and more and more. But it still looks okay for this. Still looks pretty good. Okay. So actually, I think I could simplify that. 1 through 135. So it's 1 through 17. Odd. 17. Odd. That's the same thing. I just shortened how I wrote it. Okay, so there's a lot of graphing. If you get stuck on the graphing, that's, it's new, so we'll practice it a little bit more tomorrow, and we'll go over any questions on that, and then we'll do our last section in chapter 9, which I think is actually a little easier than today.
Did you say we had a test this week or?
Friday.
Okay, we
Yep.
do.
Test on Friday.